Okay, welcome student to the integration of logarithmic functions. Here we have a new shortcut if we do the integral that produce the ln. If I have in the denominator, if I have a function in the denominator and its derivative is in the numerator. So you have function and its derivative in the numerator. So you have u and then you have u prime in the top. The integral is just ln of u. So if you have a function and its derivative sitting in the numerator, the function is in the denominator. If you have something like this, the integral is ln f of x, which is the reason because 1 over x is just ln x. So if this is u, this is u, this must be u prime. So we can do the u substitution. So we'll see the first example. If we look at this example, now if we suspect that this is u, which is y squared plus 1, we ask ourselves, what is u prime? It would be just 2y. I have the y, but I'm missing the 2. So all what I will do, I'll add half and subtract half. So in this question, the first step, we identify that the denominator is just y squared plus 1. So the derivative is 2y. So what do I need? I need to have 2y in the numerator. So you get 2y. Now I have a perfect derivative in the numerator and I have the function in the denominator. So you have this is u and this is u prime. So the answer will be just ln absolute value of u. What is u? It is whatever in the denominator. So the final answer will be just 1 over 2 ln absolute value of y squared plus 1 plus a constant of integration. Let me just repeat what I said. I look at this question, I see denominator and the numerator. In the denominator, I'll call it u. Why? Because I want to check if I can use the shortcut when we have a function and in the top I have its derivative. What is the derivative of u? It's just 2y. So all what you need to do is to add 2 and you divide by 2. So they get cancelled. Now, after I add 2 and I multiply by 2, I check that this is u prime and the denominator is just u. So the integral will be just half ln u. Let's go to question number 2, which is again the same thing. Maybe this is my u. Let me check and see. So u is 3x cubed minus 8. So u prime will be just 27x squared. Uh-oh, I don't have 27 up here. I need 27 to be here. So what you will do, you will just add the 27 x squared x. Now you are asking me, Professor, where is the 5? That's a good question. Take the 5 outside. Remember, if we have a number, we can just take it outside the integration. So I'll just keep it outside. I don't want to see it now. Keep it outside. Now, let's check. Is this u? Yes, this is u. Is this u prime? Yes, it is u prime. So you have u, and the top you have u prime. So we are in the perfect situation where we can just use the idea of the ln. It is ln of what? Remember, it is ln of u. So we just need to add u up here. And that's question number 2. Let's go to question number 3. We'll do the same thing. I have numerator, denominator, so I will suspect that this is my u, which is the thing in the denominator. Now I just need to find u prime, which is 24x power 7. Now, how would I do that? I'll just need to divide by 24. And I need the 24 to be with x power 7, so I can get exactly u prime. And of course, you are asking yourself, where is 5? Just write it down outside. Just put 5 here. And now, let's check if I am in the perfect situation. Is this u? Yes. Is this u prime? Yes. So you get u prime and u. So the answer is just len of u. So the final answer would be 5/24. And then we have len of u. What is len of u? It is just this one. And that's how we find the third question. Let's go to the next one. Again, next one, I have suspicion that I have a numerator, denominator. So you have u equal x4 plus x squared. And now you ask yourself, what is u prime? It is 4x3 plus 2x. And now, all what you need to do is just, well, actually, I have a perfect situation. I have u prime and I have u. Well, that's our lucky that we just need to write whatever u is inside the len. So remember, in this question, you don't need to multiply or divide by something else. Next question, we have the same situation. So what is my u? U is just x squared plus 4x minus 5. What is u prime? U prime is 2x plus 4. Oh, I don't have 2x plus 4. But just a minute. What happened if you take 2 as common factor? So you get x plus 2, right? Which is exactly this one, but I'm missing the 2. But I know what to do with the 2. I just can write the 2 down here. So you will have integral of 2x plus 2. And then you have the denominator, which I didn't change. It is the same. And now I'm in the best situation. I have u. And here I have u prime. If you have u prime over u, this is the integral will be just len u. That's the shortcut we just mentioned a little bit before. So the answer will be just len of whatever u is. So here we just connect with u. Now what is u? U is x squared, 4x negative 5. And that's the answer. So the only trick here is I took 2 as common factor. So you get 2 times the bracket. So you need 2 and you need to divide by 2. Last but not least, here is this one. What is u? Is 6x squared minus 4x plus 9. So what is u prime? U prime is 12x negative 4. Well, again, we are in the same situation. I don't have similarity. So maybe we need to do something here. So the idea, let's take 4 as common factor. What we get? We get 3x negative 1. And that's exactly this one, but I'm missing the 4. What should I do with the 4? Just I need to divide by the 4. So we get 4. Now we are in the situation where we have u, and here is u prime, just this one. So we are back to the perfect situation where we have function and its derivative in the numerator. So the answer would be just 1/4, and then we directly impose the len. But len of what? Len of u. Plus, of course, c. And that's the question, part 6. Let's go to example 13, which will be the last part here in this part. It says that the rate, remember, the rate means once I see the word rate, it comes directly to my mind that I'm talking about derivative. So he will give me the derivative of vocabulary memorization. Remember, if you are learning a new language or a foreign language, you need to memorize some basic vocabulary, and the derivative of how many words you will memorize per hour is given by this formula. So the derivative of v with respect to t is given to be by this, where t, of course, the number of hours, v is the number of words that you have memorized. The question is, how many words would the average student memorize in 3 hours? So I'm asking you how much v, and specifically how much v when t equal to 3. Now, how do we find v? Of course, if you want to find v will be just the integral of the derivative. Now, what is the integral of, what is the derivative? Of course, the derivative is t plus 1, and here I have 14. Well, again, the answer is the same. Imagine this is u. What is u prime? Well, you guessed it correctly. U prime is 1. So I don't need to do anything. 1 is there. Just forget about the 40. 40 can go outside, so you get only 1. So here the answer will be just 40, and then it will be ln of u. So it will be t plus 1 plus c. How do we find the number c? Remember, if we didn't study at all, we shouldn't expect that we know any word. If you didn't study, you will memorize nothing. So all what you need to do is you need to plug in 0 here and 0 here. So remember, this case, v equal 40 ln t plus 1 plus c. Now, if we plug in 0, we get 40 ln 0 again for the t plus 1 plus c. This means my c equal to 0. Why equal to 0? Because if you do this with the calculator, the answer is 0. Here is 0. 0 with 0 is 0. So you get c equal to 0. So how much is after 3 hours? It will be 40 ln. If we plug in a 3 here, we get ln 4, which is approximately, if we use the calculator and our calculation is correctly, this should give us around 55 words for 3 hours. And that's how we solve this question. Remember, this is kind of application of initial value problems.